Hey students, this is lesson 9.1. In chapter 9, we're gonna be doing transformations, and in 9.1 here, we're gonna learn how to identify isometries and to find translation images of figures. So go ahead and do the review here. There's some important vocabulary, especially the word isometry. So check that out, and you can check back for your answers. All right, so first of all, identifying an isometry, remember from the definition that an isometry is a transformation in which the pre-image and the image of the geometric figure are congruent. So if we look closely at these two objects here, they sure look the same. So I'm going to say yes, this is an isometry, and the reason is because the image is congruent to the pre-image. All right, you can try that. Check back for your answers. All right, naming images and corresponding parts. The symbolization you should notice here is that A, and that's called prime, A prime represents the image of something. So whenever you see that notation, you'll know that that's the new image of whatever you started with. So if we look at A, it says what are the images of angle A and angle B? It's pretty obvious here that the image of angle A is A prime, angle A prime. And the image of angle B is angle B prime. All right, so this notation helps us immediately know which are the corresponding parts. So the pairs of corresponding sides would be segment AB and segment A prime B prime, segment BC and segment B prime C prime, segment AC and segment A prime C prime. All right, go ahead, you try it. All right, another new word here, translation is a transformation that maps all points of a figure the same distance in the same direction. A translation is an isometry. Prime notation indicates the image points. If parallelogram PQRS is translated right 2 units, then every point on parallelogram P prime Q prime R prime S prime is 2 units to the right of the pre-image point. So, and we can use coordinate notation to help us know what that translation is. Here it says that our original points x, y, that's our pre-image, and our image is going to be such that the coordinate x is 3 less and the coordinate y is 4 more. So we can use that information to translate our image. Our original point R, taken from the coordinate grid, is 1, 2. Our original point S is 4, 1. And our original point T is 2, negative 3. And what we want to do is to get our image, R prime, we want to subtract 3 from the x coordinate. That would give us negative 2. 1 minus 3 is negative 2. And then our y coordinate, we need to add 4. 2 plus 4 is 6. And so that's our R prime, the image of R. And the image of S is going to be 4 minus 3 is 1, 1 plus 4 is 5, and our image of T is going to be 2 minus 3 is negative 1, and negative 3 plus 4 is 1. So, and then we can just draw that in there using those coordinates. So we have a point here for the image of T, and you can label that, a point right there for the image of S, and a point right here for the image of R, and our new triangle looks like that. The other thing you can do is just go right to the coordinate grid, and you know our x coordinate needs to be 3 less, so that means go, like for this R here, go 3 to the left. That would put us here, and then we need to go up 4. That would put us there. That's another way to map out the image. All right, go ahead, you try it. Check back with your answers. All right, what is a rule that describes the translation LMN to L prime, M prime, N prime? So for this one, we just need to take a couple points, like L is negative 5, negative 4, and M is negative 2, negative 3, and then look at the image points. L prime is 1, negative 1, and M prime is 4, 0. And then see how those are changed, and we can see how they're changed by looking at the difference between the points. Like to map from the x-coordinate from L to the x-coordinate of L prime, we have to, the difference between those, 1 minus negative 5 is 6, so that means we're adding 6 on that one. And then to go from negative 4 to negative 1, negative 1 minus negative 4 is equal to 3, so that means we're adding 3 there. So I'm going to guess that we are mapping our pre-image to our image by adding 6 to the x-coordinate and adding 3 to the y-coordinate. Then you just might want to check that. So if I add 6 to negative 2, right here, negative 2 plus 6 is 4, that works. And then if I add 3 here, negative 3 plus 3 is 0, that also works. So we can find a rule for the translation by using 2 points. All right, you try that. All right, we can also compose translation. So Carmen leaves her apartment and travels 2 blocks each and 5 blocks north of the library. She travels 4 blocks west and 1 block south to the grocery store. Where is Carmen in relation to her apartment? So if we think about that, let's just think of her apartment as 0, 0. So 0, 0 translates to the point, if she travels 2 blocks east, so on a coordinate system, east would be this direction, west, north, south. So she's going 2 blocks. She travels 2 blocks east. We can think of that as our x-coordinate 2, and then 5 blocks north, so our x north would be a y-coordinate of positive 5. So she goes from 0, 0 to 2, 5, and then she goes from 2, 5 to, if you go this way, from there, she travels 4 blocks west. Now 4 blocks west is a direction to the left. which would be -4 on the x-axis going left. So we need to take 2 minus 4 for the x-coordinate, which gives us -2. And then we're going to go 1 block south. South is a negative direction on the y-coordinate. So we're going to take 5 minus 1, which is going to give us 4. So we're going to end up at the coordinates -2, 4. In relationship to where her apartment is, that is, the x-coordinate is left and right, so -2 would be left 2 units, which is west. So she is 2 blocks west. And 4 is, the y-coordinate 4 would be up 4, which is heading north in a positive direction. So we're going to say she is 4 blocks north. All right, go ahead and try that. And the lesson check, error analysis. Your friend says the transformation, a triangle ABC to triangle PQR is a translation. Explain and correct the error. Find the distance between the pre-image and the image of each. So if we go from B to Q, that distance is 1, 2, 3, 4, 5. AP is 1, 2, 3, 4, 5, 6, 7, 8, 9. CR is 1. Does this transformation map all points the same distance? No, it does not. Is the mapping of triangle ABC to the triangle PQR translation? No, it is not, because remember from the definition of a translation, go back and look at that quick. Translation is a transformation that maps all points of a figure the same distance in the same direction. So since these aren't all the same distance, this isn't a translation. And we can just say not all distances are the same. From the pre-image to the image. So, if our friend said we are mapping ABC to triangle RQP, that would be a translation. All right, that's it. I'll see you tomorrow.